On an LNG-powered ship, the gas valve unit or GVU is one of the most important safety and control stations in the entire fuel gas system. Its job is to receive LNG vapor from the fuel supply line, regulate the gas pressure to whatever the engine needs, and make sure the gas can be shut off, vented, or inerted safely whenever required. In simple terms, the GVU is the ship's controlled gateway between the fuel system and the engine. It does not just supply gas, it also protects the engine room, the crew, and the machinery by managing pressure, leakage, and emergency shutdown functions. The GVU is designed to work with the engine load. When the engine demands more power, the GVU adjusts the gas feed pressure accordingly so the engine gets a stable and correct supply. It also performs a leakage test on the automatic shut-off valves before gas operation begins, which is an essential safety step. In hazardous situations, the unit can automatically isolate the gas line and inert it with nitrogen, preventing fuel gas from remaining trapped in the system. A typical GVU includes a number of key components: manual shut-off valves, gas filters, pressure regulators, automatic shut-off valves, vent valves, nitrogen inerting valves, and ventilation connections. Some systems are installed in a dedicated gas valve room, while others use an enclosed design that allows the unit to be placed closer to the engine, provided the enclosure and ventilation meet the safety requirements. The purpose of all of these parts is to ensure the gas is always under control, always monitored, and never left in an unsafe condition. Now let's talk about the process of degassing before opening the GVU. Before any maintenance or opening of gas valve unit, the gas side must be made safe. First, the gas supply is isolated before closing the relevant shut-off valves. Then the trapped natural gas inside the GVU and associated pipings is vented in a controlled way to safe location. After venting, the line is purged with nitrogen to replace any remaining gas with an inert atmosphere. This is done because even a small amount of residual methane can create an explosive mixture if air is introduced too early. The logic is important. You do not open the unit while gas may still be present. The sequence is normal isolation, venting, inerting, and verification. In practice, the crew confirms that the pressure has fallen to a safe level, that the line has been purged, and that the atmosphere is free from combustible gas before the enclosure or process side is open. The GVU and surrounding space are also monitored by gas detection and ventilation systems, so any abnormal gas release is detected early. A useful way to think about it is this: the GVU is like smart controlled gate for fuel gas. When the ship is running normally, it carefully meters fuel to the engine. When the ship is shutting down, maintaining the system, or responding to a fault, it protects the system by shutting, venting, and inerting the gas path. That is why the degassing process is not just a formality, it is a final safety barrier before personnel touch the equipment. In operational terms, the crew must follow the maker's procedure and the ship's permit to work system. The exact steps can vary by manufacturer and by whether the GVU is an open design or enclosed design, but the safety principle never changes. Remove live gas, purge with nitrogen, verify a safety atmosphere, and only then you can open the unit. If you have done correctly, this turns a potential hazardous fuel system into a controlled and maintainable piece of machinery.